Logan. In this screencast, we're going to take a look at how to write formulas of ionic compounds. So we're going to look at going from the names given to how to write the formulas. So hopefully you've looked at the previous screencast on how ions are formed and how we put them together based on charges. And hopefully you've been looking at your list of ions so we can look at the names. Here's the steps. Essentially it's 3 steps to making sure you can write the formula. The first step is we write the symbol of the cation. Now keep in mind that the cation, this piece right here, that's the positive piece in the atom. So this is usually going to be the metal. The only exception that we really have when working with this is it could also be ammonium. So those are our cations that we work with in first year chemistry. Then the second step is to write the symbol of the anion, and this is the negative piece, so it's the ion with the negative charge. The third thing is probably the most important thing to make sure we get the formula right, and that's making sure that the sum of the charges of the cation and the anion are equal to 0. So some of the important keys there is making sure that you understand the charge of a transition metal can be found from the Roman numeral. So if you have something like tin 2 with the Roman numeral 2 written after it, that would be Sn with a positive 2 charge. The Roman numeral has little to do with the subscripts immediately. That's what most students think right away, is that the Roman numeral determines all the subscripts in the formula, but it does have a bearing on the charge on the cation, which then changes the formula. Then we use the subscripts to change the number of each ion present, and if the ion happens to be polyatomic and you need more than one of them, then we're going to use parentheses around that. So let's take a look at how this works. Now I'm going to do a whole bunch of sample problems with you, about 5 or 6 practice problems here, and at any point you can pause them, read the screen, try to write the formula, and then hit play again. Our very first one is sodium chloride. That's the name given. So the first thing I'm going to do is I'm actually going to write the symbol for the cation, which is Na+1. How do we know that? Well, the symbol for sodium is Na, and then it's a positive 1 cation because it's found in group 1A of the periodic table. Chloride is Cl all by itself because our suffix is IDE, and the charge on a chloride is -1. How do we know that information? The -1 comes from the fact that this is a group 7A anion. So again, the 1A, the positive 1, is because it's in the first column on the periodic table. So then the last step that we need to do is put these 2 symbols together. So we put the Na with the Cl and make sure that the charges do in fact add up to 0. Since sodium is a positive 1 and chloride is a -1, we just need 1 of each of them. How about something like calcium hydroxide? So again, we take a look at the pieces. So the symbol for calcium is Ca. It's in an ionic compound, so it's going to be a +2. Hydroxide symbol is OH as a -1. So how do we know this? Well, we know that the calcium is a positive 2 because this is group 2A, and hydroxide, being a polyatomic ion, is on our list of common ions. So hopefully we're referring to that while doing this. So now we put these formulas together, the Ca and the OH. The last thing that we do, step 3, is to check the charges. So we've got a positive 2 from the calcium and a -1. Those don't add up to be 0. What we do need here is we need another hydroxide anion so that the sum of those 2, being -2 plus the positive 2, add up to be 0. How do we show that we need 2 hydroxides in the formula? We have to put parentheses around the hydroxide and then a 2 afterwards. That way this 2 gets distributed to both of those hydroxides inside the parentheses. It's a distributive property. How about something like lithium acetate? So again, we work this the same way. Symbol for lithium is Li. It's a group 1A metal, so it's a positive 1. And acetate comes from our common ion sheet. It's a polyatomic anion, C2H3O2, and a -1. The next step is to put the 2 formulas together, lithium and the acetate and check the charges. Since lithium is a positive one and acetate is a negative one, those two combine in a 1-to-1 ratio, and their charges add up to be 0. How about this one? Copper 2 sulfate. So again, we're going to work through this the same way. So we've got the symbol for copper. This Roman numeral 2 tells us that it's a +2 cation, and sulfate then is SO4 -2 from our common ion sheet. So now we take these two and we put them together, Cu and SO4, +2 and -2. Those two charges right here, +2 and -2, they add up to be 0 in a 1-to-1 ratio. So we're done with that formula. And hopefully you're seeing that this is fairly straightforward process. And as long as we're not out thinking it, we're going to be okay. All right, how about this one? Iron 3 hydroxide. So what we've got is we've got iron, whose symbol is Fe. The Roman numeral 3 tells us it's a +3 charge, and the oxide is O -2. So we take the two pieces and we put them together, Fe and O. Now we've got a bit of an issue because we've got a +3 charge here on the iron and a -2. So we need a common multiple of 3 and 2, which is 6. How do we get +6? Well, we'd need 2 irons. And how do we get -6? If each one's a -2, we need a total of 3 oxides. So 2 irons and 3 oxides would make this Fe2O3. And our charges now, +6 and -6, add up to be 0. Final one, ammonium phosphate. If you haven't tried one yet by hitting pause, now would be a good time to try it and see what you come up with. The symbol for ammonium is NH4 +1, and the symbol for phosphate is PO4 -3. So first thing first, we put the two formulas together, NH4 PO4. We've got a +1 and a -3 charge, so we need those to add up to be 0. So what do we need? We need a total of 3 of the ammoniums, because a +3 plus that -3 would add up to be 0. So in order to do that, we have to put the ammonium in parentheses, and then the 3 outside. Hopefully you find this to be helpful.